we're going to demonstrate Bernoulli's principle. Now, Bernoulli's principle is used to measure airspeed, and it is also responsible for airplanes flying, in the sense that they have an airfoil, a wing, and if the velocity of air on the top is higher than on the bottom, then the pressure is lower on the top than the bottom, and so the net pressure difference on the wing of an airplane is up, and that's called lift. That's why airplanes can fly. Okay? So we're going to demonstrate this with a hairdryer. It's just a simple hairdryer. And here's a balloon. I'll explain, read in the recorded lecture, a little bit more how this works, but just watch first. I'm just going to put it on low speed here. And okay, now observe what's happening. First off, the air pressure itself keeps it up. Secondly, whenever it fluctuates to the right, the pressure on the left is lower and it goes back again, and vice versa. So what it's doing is doing a very gentle oscillation. When it goes too far this way, the pressure pushes it back, and then the pressure reverses, it pushes it back again. And so this balloon is doing an oscillation. Now, it's not like the very nice oscillation of your mass on a spring. That's called simple harmonic motion. This is not simple harmonic. It's more jerky, but it is an oscillation, and that's Bernoulli's principle. If I turn it off, it will just come down. Okay? Now, it should work for every mass. Ping pong ball. Ready? This one requires more velocity because it's smaller, so it's more airflow to keep it up. So let's see what we've got here. Now let's see, how am I going to do that? Are you still going? Oh, okay. Here we go. Okay, there we go. So it's the same thing now. All right, just a different scale, that's all, but the same thing. And again, it's jerking back and forth. And, okay. It's now starting to spin. I don't know why exactly. Maybe there's a groove on one side. Very smooth, actually, but the jerky motion you can see is much smaller than the balloon. Okay, the balloon will go like 10% of its width, and this thing is also going to like 10% or 5% of its width. So that's Bernoulli. Okay? And I'll explain this more with pictures in the recorded lecture. Okay? There we go. All right?